Welcome back, I'm that Chemist, and today we have a story where somebody got kicked out of the army after they nitrated their face. I almost bought several hundred grams of thorium nitrate when I was 16. Somebody had listed it on eBay with a buy it now for only $100. Something in the back of my mind hesitated, and a little while later, it was bid on for hundreds of dollars. Would have been the deal of a lifetime, but I'm also kind of glad I don't have an absurd amount of radioactive water-soluble salts laying around in my house. I also watched an eBay auction for 25 grams of beryllium powder get bid on, and I can only hope whoever bought that comprehends just how dangerous the chemical they just bought was. Look up berylosis if you're not familiar with the hazards of powdered beryllium and beryllium compounds. It's terrifying. Beryllium is quite a toxic element. Despite it occurring early in the periodic table, it doesn't see any biological applications, and that might make you wonder why. It turns out that beryllium compounds are quite carcinogenic, and so they're something that you generally want to avoid, although you do occasionally see them in certain alloys for industrial applications. Fun fact, beryllium is actually used in X-ray crystallography because it's transparent to X-rays. This is only tangentially related to chemistry, but it will still keep you up at night. Back in the 90s and early 2000s, the chemistry department at my alma mater and other departments kept data on external hard disk drives attached to individual workstations. This was mostly fine until one of these drives failed and it was discovered that it had inadvertently been left off the list of volumes to back up. The university went to great lengths to recover the data, including sending the failed drive to an extremely expensive data recovery firm overseas. All was for naught. There were chemistry graduates that did not graduate due to the data loss. That's awful, oh my gosh. This is a cautionary tale for scientists and IT personnel alike. Are your irreplaceable data backed up? Since your hard drive hasn't failed yet, now would be a great opportunity to back it up, don't you think? I sure think so. I see a couple of recurrent themes in Chempilations, especially home chemistry mishaps. 1. Wanting to use a much larger quantity than is actually needed to observe the reaction. 2. Not knowing or not thinking about how your chemical would react with other common substances in the vicinity. For example, water, air, metals, oils, etc., if it came in contact with them. I think this is a really common theme. When you're working with stuff in a fume hood, if you're going to use fire for some reason, it is usually obvious to check around for anything flammable that you might have nearby. One of the ones people often overlook is organic waste. It's literally a jug full of flammable stuff most of the time, even if it's got some non-flammable stuff in it. There's probably a decent amount of acetone in there that would easily catch fire given the chance. If you're ever doing chemistry in any way, shape, or form, make sure you're considering the stuff around, and that includes yourself, because you're also made of chemicals, and if crap hits the fan, you're the fan that's about to get hit by that crap. My grandfather was a physicist for a large company, and when he was in school, the guy who made all the glassware on campus had a mesh floor, so whenever mercury got spilled, it would fall through the floor and pool up there, and every year during the winter, when they turned the heat on, the mercury would vaporize. Another time, he was flying with a large chunk of leaded glass, the kind used in cathode ray tubes, to stop X-rays from leaking out. And when they stuck his bag through the X-ray machine, all they saw was a large opaque object, so they opened up his bag and saw a large chunk of clear glass. So they ran it through again and got the same result, a large object that X-rays couldn't penetrate. They ended up repeating this process several times. Another one is from my high school teacher. When he was in college, he had a class where they were melting a large crucible full of metal, I think it was bronze, and the teacher gave him a pair of gloves to pick it up with. The gloves ended up catching fire while he was holding the crucible, so he asks the professor what to do. The professor says, "Oh, don't worry about it, the gloves are made of asbestos." That's the same teacher who every Halloween would blow up pumpkins using water, calcium carbonate, and a piezoelectric igniter. I'm guessing that they don't use calcium carbonate, but rather calcium carbide, because calcium carbide makes acetylene in the presence of water. Completely unrelated to the other stories, but have you ever wondered what kind of solder the US military uses? Lead-based. This is because the lead-free solder, which is massively more safe, can have tiny tin spikes grow out of it, and over time this can short stuff out. These are some great stories. This kind of reminds me of the other recent episode where we talked about mercury leaking down underneath the floor. It's surprising that he's breaking stuff with mercury in it that often. I don't know why you'd be sending stuff with mercury to a glass blower in the first place, but that's probably not too great. In terms of this other story about the asbestos gloves, asbestos is extremely effective at preventing fires. It is remarkably fireproof. However, it's also remarkably carcinogenic if you get it in your lungs. So we generally don't use asbestos in any applications, even though the concerns are somewhat overhyped. Everything is dangerous in some way, shape, or form. A while ago, in one of my classes, we were doing qualitative analysis practicals, sulfate, carbonate, and halide ions. One test was for the test of the ammonium ion, by heating the solution in question, having carried out previous tests first. We were heating the solution in a test tube over a Bunsen burner. The result that we wanted was a piece of pH paper hung over the lip of the test tube turning blue. Of course, almost all of the students put the test tube directly in the hot blue flame. This one girl took her goggles off for whatever reason, and at that moment, the test tube exploded. Fortunately, no shrapnel flew into her eyes. Unfortunately for her, her 1 molar solution of sodium hydroxide got into one of her eyes. She quickly washed it out and went to the college nurse. Thankfully, she was fine. Moral of the story, don't heat test tubes by placing them directly into a Bunsen burner flame, or take goggles off during the course of any experiment for whatever reason. In all honesty, she was very lucky for not losing her eyesight at that moment. Yeah, generally we don't heat stuff over an open flame anymore. I know we were just talking about open flames in the previous story, but it's usually not safe to heat stuff over an open flame, especially in an organic lab where stuff can all catch fire. I'm glad to hear that she didn't lose her eyesight after all this, because that would have been awful. Chemistry can be really relentless, and one small mistake can cost you a lot. One day in a university lab, I was making some substance that required me to dissolve benzyl bromide in dichloromethane. I used up the solution and sealed the flask. After the reaction, I went to wash the used flasks and beakers right away. I take the dichloromethane benzyl bromide flask, pointed upwards so the hole would face the tap, and confidently poured a bunch of hot water in. Then it hits me, a slight tingle in my nose. My eyes get teary. I thought, oh, it must be those allergies again. I try to take a breath through my nose, and the following sensation is what you would imagine snorting lava feels like. Every orifice in my face tightened up. My eyes turned bright red, and I started sneezing up blood. I just tear-gassed myself, though it wasn't too bad in the end. I was functional again in half an hour, though because my eyes were still red, people on the bus may have thought I smoked up some weed. All in all, it wasn't the worst thing ever, though I temporarily lost some sense of smell. Benzyl bromide is a potent alkylating agent, and it's also a tear gas. We actually had a recent incident in the Discord where somebody accidentally tear gassed themselves, and they were making an analog of a benzyl bromide. But their bromination was a runaway reaction, and so it ended up making a huge mess of their fume hood. Now, I'd warned them ahead of time. I'd said, just FYI, benzyl bromides are lacrimators, which just means essentially they're going to make you cry and get tear gassed. And so they said, well, it's not that volatile, it'll probably be fine, blah, blah, blah. They were driving home in their truck, and their eye was a bit itchy, so they rubbed their eye. All of a sudden, their eye started hurting like it was on fire, and they had to pull over their truck because guess what? They hadn't washed their hands well enough, and they still had a little bit of that benzyl bromide on their skin. That benzyl bromide ended up getting into their eye and tear gassed them while they were driving home. In this case, it wasn't really a tear gas, it was more of a tear residue, but they definitely learned their lesson about washing their hands properly. There are several reagents which can be tear gases like this, and so it's always good to look into structural similarity to known reagents when you're doing this sort of stuff. I've seen someone do the potassium thing, but with dry ice instead. Student in middle school tried to steal a chunk in his pocket. He made it to the door before the cold hit, and he panicked and dropped his pants. Smarter than trying to keep them on at least. Dry ice is no joke. I've got minor frostbite from dry ice before because it gets really cold really quick. And if you're squeezing a solid piece of dry ice, it will cool off the tissue that it's connected to really quickly and really effectively. The nice thing about dry ice is it'll only give you frostbite. It won't set you on fire, so that's good. Oh, you want some peroxide stories? For a while, we made some experimental polymers that were initiated with various organoperoxides. I had a charge port on the reactor equipped with a charge valve, a vent, an inert gas, a solvent wash valve, and a charge port. The material was stored in a large freezer filled with dry ice. As the engineer, I was entrusted to weigh out the charge in the lab, then dash out to the unit, a 600 or 2,000 gallon reactor, and charge it with a shot before it warmed up. Since it was in Texas, the ambient temperature was above 90 degrees Fahrenheit, and 0 Fahrenheit was considered too warm. So they had to whip this stuff out there while it was below 0 degrees Fahrenheit, and they had to get it in there as quickly as possible while the whole building was super hot. Yikes. The whole procedure was choreographed, and I practiced with a few dry runs to make sure I could get the shot charged and everything cleaned and purged to avoid leaving unused potions trapped in the piping. That would have been very bad at our process temperatures. When the shot happens, the reaction takes off and there's a thermal kick. I'm not gonna lie, it was fun. We had no incidents. Later in my career, I worked with some much larger polymerization units. Catalyst handling was automated and did not involve track and field skills. This is really funny. Another catalyst story. A polymer plant in West Virginia suffered a total disaster, and the massive fire damaged, but did not destroy, a 10,000 gallon tank of sec-butylene. For those non-chemists out there, sec-butylene is an extremely pyrophoric reagent, and 10,000 gallons of sec-butylene is probably more sec-butylene than every person watching this video combined has seen in their entire life. That is insane. The main step of preparing absinthe is distilling concentrated ethanol used to extract all of the essential oils and volatiles to separate them from lots of very bitter tannins, also extracted from wormwood in the process. I happened to have some lab glassware and wanted to try some real absinthe, not the nerfed store-bought imitation. So I bought a set of herbs, left them for a week to extract in 5 liters of 95% ethanol, then I set up an extraction involving a big pot as a water bath on a gas stove, a 10-liter wine flask with the 5 liters of ethanol with herbs in the pot, a thermometer, a condenser, and all of the needed piping. The first time I made it, everything went great, and the absinthe vanished among family and friends a bit too fast. So a couple months later, I set everything up exactly as before and started on a second batch. Despite everything being just the same as before, the extract just refused to boil. I nearly brought the water bath to its boiling point, but the ethanol just wouldn't boil, only slightly bubbling when stirred. Then I recalled from my chemistry books about using porcelain shards to facilitate boiling of substances that don't boil despite exceeding their boiling point. This is called superheating. 5 minutes later, I had a handful of porcelain shards from an old light bulb fixture, uncorked the flask, poured the shards, and the effect was immediate. The whole volume began boiling violently, reaching the top of the flask and spraying hot ethanol everywhere around. Then, a second later, the ethanol caught fire from the stove. Recall, this was 95% ethanol. And I was facing a 2-meter tall, roaring, narrow column of fire, like from a rocket engine, blowing rapidly out from the neck of the wine flask. The flame went out within a couple seconds, but now I had a large area of kitchen all sprayed with ethanol on fire. Luckily, ethanol doesn't burn very hot. I ripped the condenser hose from the tap, stuck my finger into the tap, and began spraying water around. And within a minute or so, I managed to extinguish the last of the fires. I feel lucky though that I didn't spray the now very hot wine bottle because I'm pretty sure it would shatter, releasing all of the remaining ethanol into the nearby boiling water. That would probably result in a much worse fireball. Anyway, once the shock was over and I dealt with the mess, the remaining 3 liters of ethanol produced excellent absinthe and boiled without any problems. Well, I'm glad to hear that it worked out in the end. That sounded like it was going to go really wrong really fast, so you definitely got lucky there. This is today's big story. My biggest incident happened on my 20th birthday. It's not a story I'm particularly proud of, but it fits the channel and it's interesting, so why not? So for my 20th birthday, I decided to buy some concentrated nitric acid. Don't ask me why it was legal for anyone to do so where I lived back then. And perform a nitration reaction at home. Paper goes whoosh. I had exactly 0 chemistry training back then, and what I did was essentially throwing a bit of material into the concentrated nitric acid, without a cold bath, on a magnetic stir hot plate with it turned to 30 degrees Celsius, because I thought it would keep the solution at that temperature, which I read somewhere was the correct temperature for the reaction to work. 0 chemistry training, yes? I went away for a couple minutes, and when I came back, the mixture looked dark red. I took the beaker to look at the thing a bit better, and foomp! The entire thing splashed on my face, half of it was red-brown, and because of the shock it took me approximately 2 to 3 minutes to wash it off. When I finally did that, half of my face stayed dark brown. I had very pale skin, so I literally looked like Two-Face from Batman. I called an ambulance and went to the hospital, and the doctors there didn't really know how to treat this. In fact, the attending physician wrote down that I got a liquid nitrogen burn, and released me after washing with cold water and a closer inspection. I was obviously super depressed, and I didn't leave the house for some time. Luckily, after 3 weeks or so, it started peeling off, and to this day, approximately 15 years since, my face looks like nothing happened. Oh, and I almost got erosion in my left eye due to the acid, which also solved itself within 3 weeks. This time, thanks to some actual medicine. The funniest/scariest part was that I was taking an anti-acne medication at the time, isotretinoin, which really affects the skin. But I stopped a week before the accident because someone stole the backpack with the pills inside when I was out of town, and I was too lazy to renew the prescription. A skin doctor told me that if I hadn't stopped taking the medicine before the accident, the stain would have stayed there for life. Wow. We're not done yet, though. Oh, and all of that happened while I was serving in the military, and I got kicked out of that, or rather, for not denying the accusation that the accident was on purpose, which it totally wasn't. I really did not enjoy the entire thing. I guess that's the silver lining of the story. Military service is mandatory where I come from. I guess you got out of the military in the end, which might have been a good thing for you, but yikes. At what cost? Today's yikes awardee is Daniel A. During my 3rd year undergrad labs, we were doing the Grignard reaction, which involves making phenylmagnesium bromide. I was being extremely careful to add the phenylmagnesium bromide to the reaction very carefully. Unfortunately, the student next to me wasn't being so careful, and they pushed too hard on the syringe, and it came away from the needle and wham! Phenylmagnesium bromide and THF sprayed all over the fume hood and hit both of us in the face. Thankfully, no harm was done. That is so scary. That is awful. I'm glad that no harm was done, but that is terrifying. Those chemicals are pretty toxic, so hopefully no damage was done. I don't necessarily know the toxicity of a Grignard reagent itself, but bromobenzene isn't great, so I can't imagine phenylmagnesium bromide would be much better. THF is also not great to get on your skin, so that's pretty scary. You have to be really careful when you're working with syringes because the needles can separate if you apply too much pressure, so it's good to use a wider bore needle or to just apply pressure more slowly. 2 tales, neither of which I've had the luxury of witnessing, that I've been given insight on. One of my professors spoke of a tale from his own student years. At the university, they had an X-ray diffractometer that they had themselves hooked up together, and he wanted to get some measurements done. So he turned it on, only to discover that he gets no signal. Absolutely nothing coming from the source. So after a while of troubleshooting and deep thought, with it still turned on, he eventually reached a realization. The source is pointing in the opposite direction, with the opposite direction being the wall of his professor's office. Oh no! Fortunately, nobody had been in or entered the office during the time, but given how long the source was on, all of the radiation dosimetry badges in the office had turned a nice calm, rather intense red. I'm assuming here that dosimetry badges are just like a badge you carry around in case you encounter a bunch of radiation. It's essentially like the canary in the coal mine, but for radiation in the lab. But given he left with it turned on, since you can't simply turn it on-off on a whim like a light bulb, and given the realization came only in the morning, it could have ended a lot worse. Yeah, a lot of people could have been exposed to high doses of X-rays, which is not good. X-rays can be really dangerous and can cause mutations, so that's pretty scary. A laser without a beam dump is terrifying. So yeah, if you're setting up a laser, make sure you know which way it's pointing before you turn it on. Another tale is at a glass fiber factory. During the initial warming process of the furnace, for whatever reason, there came to an excess of borate within the glass. Boron is something far too many try to cut down on as a cost-saving measure, only to later face deep regret as they realize that it is the cost-saving measure. A tale old as time in the industry. But this story is not about cutting it. Here, on the other hand, we have a story of an excess. As you may know, borates can serve both the function of a former and a flux in a glass melt. This means that an excess of boron would serve to drop the melting point of the glass dramatically. This would be relevant in borosilicate, which is a type of glass. Given the temperatures used, the glass melt, even without an excess of borates, has a viscosity below that of water. From the surveillance footage, one could see the glass flow out of the furnace, start to act a bit erratically, which the glass pullers didn't initially notice as they were talking amongst themselves since they had nothing to pull yet. Going by, one of them noticed this unstable flow, warning the others and himself to take a closer look inside. Fortunately for him, one other worker quickly dragged him out of the way, right as the glass was about to be a bit more violent. Had he not been yanked out of the way, the melt that had now splashed out onto the floor would have instead covered him from head to toe in fresh molten glass. Yikes, that is so scary. I've done some really basic work with melting glass and manipulating glass in the lab just to make capillaries, modifying pipettes or test tubes to make ampules, but working with like this much hot glass is something that's absolutely terrifying to me. We actually have quite a famous glass blower at my university who's even been featured in Numberphile, however, and he is very talented. He was actually able to chain 11 Klein bottles together, and I'll include a link to that video in the description if you're interested in checking it out. This isn't chemistry related, but I wanted to share a story that the thumbnail of Chempilation 12, titled Modesty Mutilated, reminded me of. I worked in bushland in Australia clearing house weeds. There are bull ants on these sites. The sting of a bull ant is incredibly painful and causes a lot of swelling. A guy I worked with got stung on the testicle by a bull ant near me, and 2 others. Oh no! Oh, that sounds terrible, oh my gosh. He dropped everything after giving us a short warning to look away so he could extract the bull ant. Oh no! Later he compared it to an orange. He's not talking about the bull ant, if you're wondering. Had he not done that, it would have been a lot worse than just 1 sting. Oh my gosh, that is so unpleasant to even think about. I was stung on my hand by one, and my hand ballooned up. It was tender, painful, limited my range of movement, and took a few days to return to normal. Why Australia? Why do you have to make so many bad bugs and animals? Why are all the species in Australia so terrifying? If you have any great Australian animal or insect stories, I would love to hear them in the comments. This happened to me a few years back while I was in graduate school. I was working on some carriers for genetic information, similar in concept to some mRNA vaccines that are now available. And to see the stability of nucleic acids, I ran them through gel electrophoresis. This is a way to separate big molecules based on their mass, which is something that you commonly do for separation of DNA, for instance. I always cast my own gels because I have to use specific parameters and indicators for this to properly be visualized. These indicators were best visualized under UV light, and we had a UV box to set out gels into to take pictures and such. This is like super common in biolabs. One of the postdocs in our lab occasionally would visualize gels and would open the door with the UV emitter on, to no ill effect. We had no UV glasses to be found. So of course I did the same. The difference was I had to run and visualize many more gels than he did that particular day. The next day, I woke up in the middle of the night with horrible eye pain and itching. I stumbled my way to the bathroom and flicked on the light. I did not realize the cause of my problems yet, and blinded myself because my eyes were so sensitive. It took me at least a week to get back to normal, and as of yet, I've had no long-lasting eye problems. But things could have been permanent. Always wear UV protective glasses anytime you're visualizing anything under UV, even if it's just for a few seconds. Fun fact, a few months later, another postdoc in my lab did the exact same thing, even after hearing my story, and everyone being instructed to wear glasses. Forgive me, chemistry gods. Forgive me for the DCM down the drain. Forgive me for the time I put a microliter amount of propane thiol down the drain and had to have the fire department come because they thought it was a gas leak. Forgive me for the methanol and the THF, but most importantly, forgive me for that one time I thought I was dumping my aqueous waste down the drain, and after about 100 milliliters, I noticed it was my organic. Benzene, chloroform, DCM, and acetone. Luckily, it was probably 75% acetone. Phew, I feel better already. So I have one last story for today, and this is a really good story. So I was doing this one reaction on a really large scale, and this is a reaction that I'd run several times. One of the last steps was to do an aqueous wash with saturated potassium carbonate solution. So potassium carbonate is a salt. If you dissolve salts in water, you usually get a higher density. So I was extracting from a mixture of dichloroethane with some other solvents in there, and dichloroethane is a chlorinated solvent, so it should be more dense than an aqueous layer. However, what I hadn't considered here is that the aqueous layer is more dense because there's a salt in it. So I take off my bottom organic layer, which wasn't my organic layer, it was actually my aqueous layer, and I save that, and then I take the top layer, which I thought was aqueous waste, and I just put that down the drain. So first of all, that is not a good thing to do with your aqueous waste. If it still has organic contaminants in it, you should dispose of it as contaminated aqueous waste. But I had not done that. The other issue here is that my aqueous and my organic layer were both red, like very red, very, very red. They were red enough that you couldn't tell which one was which. Okay, you could barely see the separation between the two layers. So after this, I had a second step where I was supposed to wash the organic layer with just water. So I do that wash, and both of my layers combine because I just taken the aqueous layer from the last wash. So it all combined into one big aqueous layer. So at that moment, I realized that I just put all of my organic solvent down the drain, and it was a lot. It was like 600 mils. Okay, it was terrible. So I was like, oh, I just put all of that down the drain, and I wasted my whole day. That's terrible. I feel terrible, FML. But I had this clever realization. So if you know how drains work, they usually have this U-tube. This U-tube prevents sewer gases from coming back up. And guess what? Even though the organic solvent was less dense than the potassium carbonate saturated water, it was more dense than water. So I was pretty sure that my organic solvent would still be there at the bottom of the U-tube. So I set up a siphon, and I ended up sucking the contents of the U-tube into a big flask. And guess what? I recovered almost all of the product. Now, when I finished purifying it and working it up, I had probably 60% of the yield that I should have had, and there was additional impurities that I didn't normally see, but I was still able to recover my stuff from going down the drain, and my whole day wasn't wasted. But yikes, it was terrible. Don't pour stuff down the drain. And this is a friendly reminder for you to save your washes until you're completely done and you know where your product is. Don't discard washes early, because sometimes you can undo a whole day's worth of work for doing that. Hopefully that story was entertaining. If you like stories like this, it would be cool if you could subscribe and click that bell, and I hope you have a great day.